Okay, by admitting the joining student, I will start now. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Now second Zoom ya for visiting lecturer by Dr. Muhammad Abdallah Razwan Atia from NRC Egypt ya in class of mineralogy class A after midterm ya. Okay, I start again. Continue ya tadi. Share.
The oxide need to make porcelain clinker. These oxides are calcium oxides, silicon dioxides, aluminum oxides, and iron oxides. And these oxides can be provided from different sources, like calcite is a source of calcium oxide, calcite, limestone, aragonite, seashells, even marl. Can be a source of calcium oxide. Regarding
Please write down the question along presentation in video in chat Zoom ya. Okay.
The iron oxide, which gives the gray color of the cement, can be obtained from limonite, clay, shale. Silicon dioxide can be provided from sand, shale, clay, even marl, because all these sources contain silica in their structure. Aluminum oxide.
I'm sorry, Dr. Muhammad Razwan. I hope you can on cam, although not continuously ya. Please on cam.
Can be provided from bauxite, clay, or shale. The manufacture of cement or Portland cement. The manufacture of cement consists of the following steps. First step, the chemical analysis must be conducted to each raw materials, and these figures show the processes of the manufacturing of OPC or Portland cement or cement in general. Firstly, the materials from quarries must be chemically analyzed to check their chemical oxides. Then, after checking, these raw materials are mixing in definite proportions, and then grinding these materials in a big mill. Then preheating these materials are input in a rotary steam kiln and preheating, then fired at high temperatures of about 1,300 to 1,500 degrees centigrade. The clinkering at the final is formed like this. This figure shows a clinker of dark gray nodular shape, and the diameter of this clinker ranges from 4.5 to 2 inches in diameter. This clinker has a new chemical compounds different from the original or the raw materials. And we will speak about these components later on. The clinker was very hot, and then air cooling and then grinding. After air cooling of the clinker, a few percent of gypsum, from 3 to 5% of gypsum, are added or we added to the clinker after cooling and then grinding together. And the importance of the gypsum come from the regulating the setting time, because without gypsum, the clinker, the produced clinker, when reacts with water, is completely set without time. So we add a few percent of gypsum from 3 to 5% to regulate this setting time Although it improved shrinkage and strength development to the mortar or concrete produced. The grinding or the finance of the produced clinker maybe 100% of the produced with minus 75 microns. Uh, Now we would like to speak about type of cement. There are two approaches are normally used to classify cement. The first approach based on the composition, and second approach based on the performance, like strength, setting times. Two international classifications of cement are widespread. The first one is a European standard EN 187/1, which is titled Composition Specifications and Conformity Criteria for Common Cements. According to this standard, 27 distinct common cement products. For example, CM1, CM2, CM3, CM4, CM5, etc. And seven sulfate-resistant common cements. For example, CM1, SR0, SR meaning sulfate resistant, 0 meaning C3A is 0 content or 0%, and CM3, TSR, etc. The other standard or the other international standard that classify cement are ASTM or American Scientific Testing and Material Standards. And this standard, there are two specifications for cement classification. C150 is the standard specification for Portland cement, especially for Portland cement. Classifies the cement into two types of Portland cement, like type 1 or type I, type IA, type 2, type 2A, type 2MH, type 3, type 4, and type 5. And the other standard specification is C595, and this is related to blended hydraulic cement. According to this standard, four types of blended hydraulic cement are classified, like type IS, type IP, type IL, type IT, and these abbreviations we will speak about them later. Also, this is there were six types with special properties, like type IS A, type IS MS, type IP HS, and so on. And this table this table given notes on the common types common cements by European standard according to composition. As we see in this table, there are four main types of cement: CM1, CM2, CM3, CM4, and CM5. And each one of these main types are divided into one or more divisions or subdivisions of totally 27 products. CM1 meaning Portland cement, which is the most common cement type all over the world, CM1. And CM1 is composed mainly of clinker from 95 to 100% clinker. With minor additions like 0 to 5% minor addition like limestone, like any type of addition except main constituents. We can see also there are several main constituents that form this common type by European standard, like plaster's slag, silicate loam, and pozzolana, whether natural or natural calcium, fly ash, whether siliceous or calcareous fly ash, burned shell or burned clay, and limestone L or double L, and L or double L depending on the TOC, total organic content. The other type, like SIM2 is composed of many subdivision, like Portland slag cement, according to what type of main constituents are included to manufacture this type. For example, Portland slag cement are composed of two subdivisions, SIM 2AS and SIM 2BS. S meaning slag, and A is the amount or the percent of clinker in this type of cement. For example, SIM to AS, the clinker from 80 to 94% and phosphorus slag from 6 to 20% of slag the waste. Another example is by Portland silica fume cement. And this name comes from the type of main constituents that has been added to the clinker. If we add silica fume, so the cement name is Portland silica fume cement. If we add pozzolana with the natural or calcined, the produced cement is named Portland pozzolana cement. And for pozzolana cement, there are four subdivisions. As you mentioned, according to the percent of clinker and the percent of the natural pozzolana and the type of pozzolana, whether natural or calcined, and so on. And simply is a from top to bottom, we can see that the cement, the amount of clinker decrease, and the cement name is reversing. Firstly, Portland slag cement includes a few percent of phosphorus slag until a maximum 35% of the slag. But phosphorus cement is a reverse name. Why? Because it's composed mainly of slag until maybe 95% slag or 80% slag or 65% slag cement with a few percent of clinker. Also, the same manner in pozzolanic limestone and composite cement. For composite cement, in this type of cements, I think all or more than one type of main constituents are composed, like blast furnace slag and pozzolana, whether natural or calcined, are used in this type of cement, which is composed cement. Another types of cement by European standard is sulfate-resistant cement. And according to the phase contains the percent of the phase C3A tricalcium aluminate, there are three main types of sulfate-resistant cement, of totally 7 types of sulfate-resistant cement. C1, sulfate-resistant Portland cement, and this is classified into three subdivisions: C1 SR0, C1 SR3, and C1 SR5. The same percent of clinker, but the phase composition is different because in this case, sulfate resistant C3A or tricalcium aluminate phase in this type of cement range from 0% to 5%. Because why we speak about C3A in this type of cement, sulfate resistant cement? Because C3A is the main when there are more percent of C3A in the cement. This means this cement is not resistant to sulfate. If we put the concrete in a soil of water of high sulfate components or content, this concrete may be deteriorated. But if we decrease or if we lower the content of P3A in the cement, so the cement will be sulfate resistant. SIM2 or SIM3 sulfate resistant fluorescent slag cement. And finally, SIM4 sulfate resistant pozzolanic cement. In this type or this, there are two subdivisions. same for ASR, and same for BSR. And the amount of C3A in these two subdivisions must not exceed 9%. 9% C3A. Now we will speak about the common cement according to EM, but based on performance. Performance here, we will speak about comparative strength, initial setting time, and soundness that expressed by expansions. The comparative strength, according to the comparative strength, there are three main or three classes. First class, 39.5 and 30 and 49 and 42, 32.5, 42.5, and 52.5. This is according to the standard compressive strength at 28 days. For example, at 20 days, 32.5 strength class, meaning the mortar. I will tell you something. The compressive strength here is not for cement only, no, for cement and sand, for mortar mix. We make a mortar mix and measure the compressive strength at 2 days, 7 days, and 28 days. At 28 days is the standard strength that classify the cement 32.5 mean 32.5 megapascal. 32.5 megapascal. So the cement of minimum 32.5 megapascal at 28 days, and the other class 42.5 megapascal as a minimum and maximum 62.5. Finally, 52.5 minimum megapascal with no maximum limit. And according to air strength, sometimes we need cement to be airly strengthened, or we mentioned it, rapid hardening. In this side, the cement are classified in two classes: ordinary class N and high R. That means there are six strength classes: 32.5 N and 32.5 R. And this is according to what? According to the strength at early ages, like 2 days and 7 days. Especially 2 days. Another type or another performance parameters, initial setting time. Initial setting time for class 32.5 must be more than or equal to 75 minutes. Here, initial setting time in minutes. And for 2.5 must be more than 60 minutes. And finally, for 52.5 plus strength, the initial setting time must be more than 45. And for expansion in millimeter, all classes not exceed, the expansion of the mortar not exceed 10 millimeters. And this classification, the other table, according to the chemical composition, like C1 and C3 for all strength classes I mentioned before, loss and ignition not exceed 5%, and sulfur residue not exceed also 5%. And for sulfate content, this is a very important part of this table. Sulfate content for CM1 to CM5, according to the strength class, not exceed 3.5%. And this is very important in the soil or the environment which contain percent or proportions of sulfate, like seawater, like soil that high content of sulfate, as SO4 or SO3. Now we will speak about the constituent, the main constituent of semen, as shown in the table before. The table, this table uh, show that the main constituent of the Robin standard are as follows. Portland semantic linker explained by centering a precise lectures of the materials as mentioned before, and second constituent, second main constituent, granulated reference slag prevented by S, which is made by a rapid cooling of slag smelt as a iron ore or by melting iron ore into a furnace, the manufacturing of iron. The third type is a polyorganic material, P or Q. Polyorganic material is any natural substances, volcanic origin or sedimentary origin, that are characterized by their composition siliceous or silicio-aluminous composition, high silica and high alumina. And this subdivision of pozzolanic materials, natural pozzolana and natural calcined pozzolana. And this type of calcination means activation of the pozzolanic material by thermal treatment maybe up to 80 or 90, 900 degrees centigrade for activation to be used as a pozzolanic material. Also, fly ash, B or W, fly ash, this is obtained from the burning pulverized coal in power station. The power station for electricity used coal, maybe previously, but now is natural gas or even nuclear station. And this there are two subdivisions of the fly ash: siliceous fly ash with at least 25% reactive silicon dioxide, and calcareous fly ash W with at least 10% reactive calcium oxide. Another main constituent of cement, burning shell, produces at temperature, as mentioned, approximately 800 degree or sometimes 900 degree according to the type of shell or type of shell. Limestone must contain at least 75% calcium carbonate as a mineral, calcite, and its clay content not exceed 1.2 gram per 100 gram calcium carbonate. And total organic content not exceed 0.2% for LL limestone and 0.5% for L limestone. Finally, silicate fume is a byproduct of manufacture of ferrosilicon alloys. And this type, all these types main or form the main constituent of sealing. In addition to minor addition constituent like fillers, which not exceed 5% of the total mass of cement. Calcium sulfate is also added to the manufacture of cement at the end of the manufacturing step. And gypsum and hemahydrate are a mixture of these measures. The other type of cement, the other standard that classifies the cement is the ASTM or American Standard. American Standard, there are two specifications, C150, which classify the Portland cement into several types, like type 1, which name normal or organic Portland cement according to the chemical composition. Chemical composition here is aluminum oxide, ferric oxide, magnesium oxide is the maximum, sulfur trioxide is the maximum. When P3A is 8% or less, or C3A is more than 8%. Also, ignition in silver residuum. In addition to phase composition, C3S, tricalcium silicate, C2S, dicalcium silicate, C3A, tricalcium aluminate at the maximum or minimum percent must be satisfied in the type of cement. For type 1, this is normal or ordinary Portland cement. For example, percent of aluminum oxide for type 1 not specified. So any percent of aluminum oxide. Uh, and for example, magnesium oxide for type 1 must not exceed 6%, 6%, and sulfur trioxide not exceed from 3 to 3.5%, and so on. Type 2 is named moderate sulfate or heat resistant cement, and moderate sulfate. And this type of cement is used in the environment that are contain some sulfate content as SO3 or SO4. Uh, type 3 is a higher air strength or rapid hardening cement. And this type of cement we are using it especially in the cold weather or in the project which uh, we must open this project quickly. So we use this type of cement in the construction. Type 4 is the low heat of hydration or low heat cement. And this is the commonly used in the mass construction like them which produced a high content of heat in joule. And finally, type 4 or type 5 is a high sulfate resistant cement like type 2, but in the area or the condition of very high content of sulfate content. So we use this type of cement in the construction. And this is a subdivision of these 5 types. Type AA, the same purpose, but with air entraining cement. Air entraining cement is admixtures are used or are added to the cement, especially for in the cold weather for freezing resistant admixtures. Another type of cement is the blended hydraulic cement by American Standard C 595 based on composition. And there are four main types of blended hydraulic cement according to the compositions. Type IS is a Portland cement mixed with blast furnace slag. So S is the slag cement. Type IP the Portland pozzolanic cement. Pozzolanic cement with a natural pozzolana or artificial pozzolana. Type IL Portland with limestone content. Type IT is a ternary blended cement, maybe some percent of pozzolana plus percent of limestone and percent of the slag cement. Special properties of blended cements here are also mentioned. And take symbols A, meaning A, air entrained air cement. MH, moderate heat of hydration cement. And MS, moderate sulfate resistant cement. And HS, high sulfate resistant cement. And LH, low heat of hydration. And R, resistant to alkali reactive silica aggregate expansion. And according to performance, American Standard classifies the Portland cement based on the compressive strength, based on the setting time, as in European standard. But the numbers are different from the European standard. The compressive strength also after mortar making or mortar preparation, and we measure the compressive strength of the different type of cements at 1 day, 3 days, 7 days, and 28 days. And every type of cement you should use or you will use in your construction or your project must satisfy these parameters like finance or specific surface area, like air permeability, like air content in mortar or expansion by autoclave, strength in mortar cubes at four curing days, and finally setting the time of the cement. Not less than in minutes, not less than 45, and not more than the final setting time.
Jangan lupa ngisi presensi ya.
Not more than 375.
Presensi di link Zoom. Ya, Bib ya, jadi sudah ya. Silakan diisi. Masih 18 orang yang ngisi.
For all cement pipes. And this blended cement according to performance. Also, we should check the initial setting time by VTech in all type of cements like IL, IT, IIS, and IT, and compressive strengths 3 days, 7 days, and 28 days. Also for special properties like air entrained admixtures like MS, MS mainly moderate sulfate resistant and HS high sulfate resistant and so on. We should check all these parameters to specify even if this type of cement in one satisfy the requirement or not. This slide, we will speak about the ingredient or the component of Portland cement and blended cement according to American standard. Portland cement according to ASTM C150 composed mainly of Portland cement clinker added in addition to calcium sulfate and limestone not to exceed 5%. Sometimes we put or we add inorganic processing addition not to exceed 5%, and sometimes organic processing addition not to exceed 1%, and sometimes air entrained addition. While in blended cement, as its name implied, in blended cement composed mainly of Portland cement or Portland clinker cement, slag or slag cement, Portland limestone hydrated in different proportions. All these components in different proportions, not specified proportions, different proportions that, but one condition that achieve the requirement we mentioned before, the physico-mechanical requirement. The component of Portland cement after making. Portland cement are composed mainly of as a chemically component four main oxides, which form around 90% of the cement. So 90% of cement are composed mainly of calcium oxide, silicon dioxide, aluminum oxide, trioxide, iron oxide, and amine constituent. While around 10% minor like magnesium oxide, alkalis, sodium and potassium oxides, sulfur trioxide, and titanium oxide, and phosphorus oxide. Regarding the phase composition, OPC or Portland cement are composed mainly or 85 to 90% composed of C3S, C2S, and C3A and C4AF, which are abbreviated to tricalcium silicate, dicalcium silicate, tricalcium aluminate, and tetracalcium aluminate fluoride, halide, belite, salide, and fluoride. While 10 to 15% minor procedure like gypsum and hydride and free lime, which are not actually reactive. Not all calcium, not all limestone are calcium oxide sometimes, or not all limestone are react to silica. Some free lime are free, not reactive with silica or with aluminum or with iron, are found free in the cement component. And this table show the average composition of different types of Portland cement from I, triple I, 4 and 5 cement, silicon, aluminum, iron, calcium, magnesium, sulfur. In addition to the potential phase composition of C3S, this is S, not zero. C3S, C2S, and C3A, and C4A, the range, the minimum and maximum, and the average values. And the last column shows the clean finance of the surface area of the cement. With increasing surface area, meaning the high grinding effect, and this is high, the high clean finance indicate high air strength cement. Properties of these phase components. Here we have four main phases and some minor phases like gypsum. Four main phases. C3S. C3S is a tricalcium silicate which hydrates and hardens rapidly, and this is responsible for initial strength or early strength of cement. So this phase is responsible for the early strength and early hydration of cement. While C2S is in contrary, because it's hardening slowly and hydrating slowly. So its strengths maybe appear at late age or maybe after 1 week, the strengths appear. The third type of third phase composition is the C3A. This type of composition liberates a large amount of heat. So this type must be, this component must be lower in the cement because a large amount of heat may be damage for mass concrete. The last one, C4AF. This type of phase is the responsible for the color of cement. The gray color of cement is according to the percent of alumina and iron, especially iron, and magnesium. And as we mentioned before, calcium sulfate is added to cement for setting or controlling the settings and improve the shrinkage and the stress development of the concrete. And this shape or this figure show the reactivity of different phase composition. As we see that the high phase activation or the reactivity of the high phase is tricalcium aluminate, and the last one or the minimum or the lower one is a dicalcium silicate. The application of different Portland cements. Type 1 is suitable for all purpose, especially or except if we don't require any special properties like heat resistant or sulfate resistant or any special property of cement. Type 1 is suitable for all